The electromagnetic spectrum. Now, this is one wild topic. We're not even going to scratch the surface with this problem, but I went ahead and got this off the internet so that we kind of understand what this problem is talking about, because it's quite confusing. So let's just go through it. The width of a wavelength in the visible light region, which is this tiny little region that they kind of blew up for us right here, or basically the region where human beings can see. So the width of that spectrum is 4.6 times 10 to the negative 6 meters. Another wavelength in the microwave portion of the electromagnetic spectrum has a width of 3.2 times 10 to the negative 2. And here's the microwave spectrum here. So as you can see, increasing wavelength. As we go to the right, the wavelength is increasing. So the visible spectrum, let's say, has waves pretty close together like that, whereas as you go to the right, that wavelength is kind of getting, I guess you could kind of draw it like this in a way. It's just getting bigger. So, you can fit multiple visible spectrum waves inside of the microwaves. So that's just kind of an intro to this problem. So, how many wavelengths of visible light, if laid side to side, will fit within one length of the microwave wavelength? Express your answer in scientific notation, which basically just means some integer times 10 to some power. That's scientific notation. So, we kind of talked about it right here already. How many? 4 times 10 to the negative 6, a lot smaller than 3.22 times 10 to the negative 2. Okay? So basically, how many of these, can fit into these? Well, if I were to ask you how many 5s can fit into 100, you would just go 100 divided by 5 equals 20. So 20 5s go into 100. So for this one, we're just taking the larger number, 3.22 times 10 to the 6, times 10 to the, 3.22 times 10 to the negative 2 over 4.6 times 10 to the negative 6. And that's going to equal, now remember, 10 to the negative 2 divided by 10 to the negative 6, we just subtract. So it would be negative 2 minus negative 6, which is positive 4. So this is going to end up being something times 10 to the 4. So now we just have to do 3.22 divided by 4.6. So 3.22 divided by 4.6 is 0.7. So this is just going to be 0.7 times 10 to the 4. Now, there is no 0.7 times 10 to the 4, but there is a 7 times 10 to the 3. So if we move the decimal place over to get 7, we have to move it in the opposite direction for 10 to the 4. So we're increasing the 0.7 to 7. We're decreasing the 10 to the 4 to the 10 to the 3rd. So 7 times 10 to the 3 is your answer. I hope that makes sense.